Okay, silly me. Sorry about that. So thanks for clicking on another link. I have 4 examples now. That's what I was looking for. It was on my other piece of paper. So look at all these. Notice that you have different variables in some places, right? A couple with x, a couple with some other stuff. That's going to tell you what variable to use as you integrate if it's unclear to you. So what function has a derivative of 9 if your variable is x? Would be a way to look at this first question. And the answer for that would be 9x, and then we could have a constant. The next one, we want to use power rule. So go up 1 and divide by that new exponent. So keep the 2, go up 1 power, divide by that power, and then I can have a constant. Now, the wonderful thing about learning a math process that's the reverse of something you already know, is you could just differentiate, right? Look at this and say, okay, I'll take a derivative. Do I get that? All right, if you don't, you did something wrong. But hopefully that's all good. All right, the next one, the dp, reminds me that my independent variable is p. And in this last one, we want to be a little careful about what w to the second means on the bottom. So I'm going to stop talking for a hot sec. Try these two. You can pause if you want. And we can come back and check your answer. Okay, hopefully here you have this or the equivalent. I don't care if you tidy things up or not. The back of the book kind of answers, like the online answers, are often going to simplify. Remember that in AP Calculus life, right, it does not matter to the readers if you have, taken -4/2 and written it as -2. Do not care, okay, which is kind of nice. All right, this one, I'm going to think of this first piece like it was 3w to the -2nd. That's just in my thinking, okay? My answer, my antiderivative, is going to involve going up 1. Now, sometimes people get confused about which way up is with negative exponents. This is going to take us to w to the -1. So my antiderivative involves -3w to the -1, also known as -3/w. And then here, we need to go up 1, but it's a positive exponent, so now don't get mixed up. Okay, that's w to the 3rd in that term, and then plus a constant. This is just a quick mention of a topic that's going to be bigger in your life later on. If you have, and we actually saw this earlier already, a differential equation just is an equation that involves derivatives. Okay, that's all. So anytime we have something that's like dy dx equals blah, blah, blah with x in it, what we would like to do as a way of solving it is to first do what's called separation of variables. FYI, not every differential equation in the universe can be separated. However, every differential equation in the universe of Calc BC can be separated. When you take another class in your life called differential equations, you'll see some other ways to solve these guys. But every differential equation in BC Calc that you are asked to solve will be separable. So separation of variables means you put all the x-type things on one side, all the y-type things on the other. So it's as if I just multiplied through by dx. That's a little bit of being fast and loose with what dx means, but it works, okay? Then we're going to integrate both sides. And so we think about having this 1 here. What function has a derivative of 1 with respect to y? That's y. And over here, I would have my capital F, that's me trying to write a capital F, relative to x. And then we could actually think about this as having a constant of integration on both sides. Those constants would not necessarily be the same, so I might call them C1 and C2. But if you think about the nature of constants, we could just not have a constant over here and have a different constant on this side. And that's usually what is traditionally done, right? If I have plus 10 on one side and I have plus 12 on the other side, that is the same as having plus 2 on the one side. Okay, that's what I'm talking about. So you just pick a side to have the constant on. Usually we pick the side with the x, okay? So that's the format that we would get. If we start out with a differential equation, we're going to end up with something that's the antiderivative of this with a constant. So here, we start out, we have this differential equation, and it says our solution curve goes through 2, -3. So first step, separate. Second step, integrate. This side gives me a y plus a constant, but I'm going to really just absorb that constant on the other side. We're going to anti-differentiate this guy, and we're going to go up a level, divide, so that would be 1/2 or 2/4 x to the 4th. And then we're going to have go up 1, so that would be 3x squared, or 6 over 2 as your coefficient, and then minus 5x plus a constant. Now I can bring this point in and say, well, it is true that if y is -3, x is equal to 2 at that same moment. And that particular point allows me to figure out what that constant is. That's -13. Okay, so then we substitute that back in, and we know, therefore, that our overall original curve was this 4th degree polynomial. And I'm just going to slot in that value of -13. Okay, so a question like that might come your way. It's not really any different than any of the integration problems or the anti-differentiation problems. It's just a matter of you do actually get to find the particular C. There are 4 questions at the bottom here. I definitely want you to pause, okay? Work all 4 of these questions and then come back and look at the video, and then I think you're done. That's exciting. Pause. Okay, you're back from the pause. So number 1 should be straightforward right out of the box. Number 2 is there because of my experience with people getting confused about roots and denominators and negative exponents versus fractional exponents. The square root of x is x to the 1/2. 1 over square root of x is x to the -1/2. If you think of the original pieces of the integrand like that, you should get the answer I have there, okay? Number 3, very important question. My calculus class of 2016 is responsible for this term. Manam danam ba ba da da da. Right? Like, didn't you listen to Sesame Street? Come on, you had a sad childhood if no, okay? But a monomial in the denominator is what we're referencing here, and that is what we have. We do not get to integrate the top and integrate the bottom, friends. No, 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 that is not how that works. If you did that, I dare you, I double dog dare you to take the derivative of what you wrote as your answer and see if you get the original. Because you know what? You won't, okay? So that's not what's happening here. What we want to do is use our algebra to help us do our calculus. So do you see the little bubbles I'm drawing here? Yeah, that's the scoop. So do that, and then you will get this beautiful guy over here, which you can nicely write into calculus-friendly notation and find the antiderivative. And honestly, if you do take the derivative of this and then do some algebra, you'll get back to the original. Okay, that's a worthy study problem. Definitely study that. People get that wrong a lot. Okay, question 4, again, algebra helps you to do the calculus. Okay, so you just need to distribute here, and that should leave you with some recognizable integrals. Okay, recognizable things to anti-differentiate. Okay, thank you so much. Sorry about the 2-piece video. All right, talk to you later. Bye.